Rationale for reducing project duration. Time is money. Cost time trade-offs. Reducing the time of a critical activity usually incurs additional direct costs. Cost-time solutions focus on reducing or crashing activities on the critical path to shorten overall duration of the project. Reason for imposed project duration dates: 1. Customer requirements and contract commitments. 2. Time to market pressures. 3. Incentive contracts or bonus for early completion. 4. Unforeseen delays. 5. Overhead and goodwill costs. 6. Pressure to move resources to other projects.
Options when resources are not constrained. 1. Adding resources. 2. Outsourcing project work. 3. Trading over time. 4. Establish a core project team. 5. Use twice, less and production. Options when resources are constrained. 1. Improve the efficiency of the project team. 2. Best practice. 3. Critical change. 4. Reducing project scope. 5. Compromise quality.
Project cost duration graph because considering direct and indirect costs for specific project duration. Critical activities are researched to find the lowest direct cost activities that will shorten the duration of project. Total costs for specific project duration are computed and then compared with the benefit of reducing project time before the project begins or while it is in progress. First, we go to what the meaning of direct cost. Direct cost is commonly represent labor, material, equipment, and sometimes subcontractor. Direct costs are assigned directly to a work package and activity. Hence the term. The ideal assumption is that direct cost for an activity time represent normal cost, which typically mean low cost efficiency method for a normal life. And indirect cost. Indirect cost is generally recipient overhead costs such as supervision, administration, consultant, and interest. Indirect cost cannot be associated with any particular work. Now we see at the graph of project cost. Like we see, the total cost for each duration is the sum of the indirect and direct costs. Indirect costs continued for the life of the project. Any reduction in project duration means a reduction in indirect costs. Direct costs on the graph grow at increasing rate as the project duration is reduced from its original planned duration. With the information from the graph such as this for project, manager can quickly judge any alternative such as meeting a time to market deadline.
So now we will learn about constructing a project cost or making duration graph. To constructing a project cost or duration graph, we need to find total direct cost for the selected project duration, and then we find total indirect cost for selected project duration. Third, we sum direct and indirect costs for the selected project duration. So we sum both of the total cost, and then compare additional cost alternatives for benefits. After that, we determining activities to shorten the activities with the smallest increase in cost per unit of time, with assumption: first, the cost relationship is linear. Second, normal time assumes low cost efficient methods to complete the activity. Third, crash time represents a limit or the greatest time reduction possible under realistic condition. 4. Slope represents a constant cost per unit of time. And 5. All acceleration must occur within the normal and crash time.
Hello guys, my name is Ali Akbar Irawan. In chapter 9, I will explain to you about a simplified example. A simplified example is a case about how to reduce a total cost of project by a duration time of the project. Can be seen in the table. the project has a duration of 25 days with a total direct cost of $450, if the project duration is reduced, whether to give the total the direct cost cheaper? If so, what is the duration of time that resulted the most share of the total direct cost? For the duration 25 days, resulted in total direct cost is $450. If the project duration is reduced to 24 days, then the A activity reduced at 2x the slope cost is $20. The total direct cost is $470. If the project duration is reduced to 23 days, then the activity day reduced to 10 at a cost of a slope is $25. The total direct cost is $495. If the project duration is reduced to 22 days, then the F activity reduced to 4x. The slope cost is $30. The total direct cost is $525. If the project duration is reduced to 21 days, then the activity of C reduced to 9x. The slope cost is $30. The activity day reduced to 9 at a cost of $25 of the slope cost, and C activity reduced to 7 with a slope cost is $30. The total direct cost is $610. From sum of the time of the variation in the table, judging that the time duration of project yielding the most inexpensive cost is 22 days with a total cost is $775.
Practical consideration using the project cost duration graph to be able to compare any proposed alternative or change with the minimum cost and times. More importantly, the creation such a graph keep the importance of indirect costs in the form of decision making. Indirect costs are frequently forgotten in the field when the pressure of the project is intense. Finally, such a graph can be used before the project begins or while the project is in progress. Creating the graph in the pre-project planning phase without an imposed duration is the first choice because normal time is more meaningful. Manager may choose not to use the formal procedure demonstrated.
Crash times. Collecting crash times for even a moderate-sized project can be difficult. The meaning of crash time is difficult to communicate. What is meant when you define crash time as the shortest time you can realistically complete an activity? Crash time is open to different interpretation and judgments. Some estimators feel very uncomfortable providing crash times. Regardless of the comfort level, the accuracy of crash times and cost is frequently wrong at best when compared with normal time and cost. Linearity assumption. Because the accuracy of contrast activity timings and cost is questionable, the concern of some theories is seldom a concern for practicing managers. Reasonable pre-comparison can be made using the line assumption. The simple approach is adequate for most projects. There are rare situations in which activities can be crashed by single-time units. Instead, crashing is all or nothing. For example, activity will take
10 days or it will take 7 days, but no option exists in which activity will take 8 or 9 days to complete. In a few rare cases of very large, complex, long-duration projects, the use of present value techniques may be useful. Such techniques are beyond the scope of this text.
There are other factors that should be assessed beyond simply cost. First, the inherent risks involved in CREST particular activities need to be considered. Some activities are riskier to CREST than others. For example, accelerating the completion of a software design code may not be wise if it increases the likelihood of error surfacing downstream. Second, the timing of activities needs to be considered. Crashing an early activity may be prudent if there is concern that subsequent activities are likely to be delayed and absorb the time gain. Third, crashing frequently results in over-allocation of resources. The resources required to accelerate a cheaper activity may suddenly not be available. Resource availability, not cost, may dictate which activity are crashed. Finally, the impact crashing would have on the morale and motivation of the project team needs to be assessed. If the least cost method repeatedly signals a subgroup to accelerate progress, fatigue and resentment may set in.
What if the cost, not time, is the issue? So what if the cost that will be our target and not the time? So basically, we will do just scaling back the scope of the project can gain time. Delivering last what was originally planned also produce significant saving. The second option is having owner take one more of responsibility. So the owner will take more of the responsibility of the activity that we must complete. The third option is to get the project to be outsourcing to the another project management. The fourth is using brainstorming, so we might get another option to make the project cheaper.